Discuss about hazard. So before we start hazard, we should know at which stages the operation do what. So let's say we'll take the example of one ALU operation and we'll see at which stages what it does. Add R1, R2, R3. We know that R1 is equal to R2 plus R3. But how it happens? Okay. So in the fetch stage, we are doing the fetching the instruction. In decode stage, we are reading the operand. So A is equal to R2, B is equal to R3. Now in execute stage, the ALU output is equal to A plus B. That means A is your R2, B is your R3. That means R2 plus R3 and happened in the execute stage. In the memory, there is no memory access, no memory read, no memory write, no operation. In the write back stage, we are writing onto the R1. So what will write? ALU output. So ALU output will written into the R1. Now, in the load operation, here's the example: load R1, 20 within bracket R2, which means R1 is equal to memory of R2 plus 20. Okay. Now, in the fetch stage, we are fetching the instruction. Decode stage, we are reading the operand. So, we are reading R2 and we are reading the immediate field. So, A is equal to R2, B immediate is equal to 20. Now, in execute stage, what we will do? We are calculating the effective address. This is what your effective address. That is your R2 plus 20, or you can say A plus immediate. A plus immediate. Next, in the memory stage, we will read from the memory. Load means we are reading from the memory. So, at what address you will read? From which address? That address is this ALU output contents. So, in the memory of ALU output, we will read and it will store into the LMD register. Load memory data register. Okay. Now, in the write back stage, we are writing into the R1. So, from what you will write? From what you will take the data? From the LMD. So, LMD, the content of LMD written into the R1. So, see, at the execute stage, we are adding these two to get the effective address. At memory stage, we are reading from the memory, okay, and storing into the LMD, and write back, we are writing into the R1. Now, another example, store operation. R3, 40 within bracket R4. So, first IF, we are fetching the instruction. ID, we are reading the operand. Okay, so A is equal to R4, B is equal to R3, and immediate is equal to 40. So, ALU output is what? A plus immediate. A plus immediate, which is the effective address. Okay. Now, so what store means? In the memory you will write. In memory stage, you will write into the memory. At which address you will write? That is your ALU output. Okay, that effective address. Memory of ALU output. What you will write? The content of R3. So, content of R3 present at what? B temporal register. So, B will be written into the memory of ALU output. Write back, no operation. Okay. So, this is the brief details regarding your instruction. Remember, ALU operation at ID stage, we are reading the operand. Execute stage, we are doing the ALU operation. And memory, there is no operation. At the write back, you are writing into the registers. In load, at ID stage, we are reading the operand. At execute stage, we are getting the effective address by adding these two. Then, at memory stage, we are reading from the memory. We are accessing the memory. Here we are reading purpose. In the write back, we are writing into the register R1. In the store operation, At IT stage, we are reading the value of R3, R4, 40, storing in the temporary register. At the execute stage, we are adding these two to get the effective address. And in memory stage, we are we are writing into the memory, and in write back there is no operation. One concept you should know. Let's say we have three instruction and the instruction process through the fetch, decode, execute, memory, write back. Fetch means you are fetching from the instruction memory. Decode means you are reading the register operands. Execute means you are doing ALU operation like addition, logical operation, arithmetic operation. In main stage, you are accessing data memory. In write back stage, you are writing into the register. Now, so you can see in IT stage and WB stage, we are using register. Okay, here the second half clock cycle in the IT stage are the solid and the first half part are the dotted. So you can see the write back. Here the first half is solid line, second half is dotted line. Why? Because to read, so here we are doing what? Reading. So to read the register, we can do in half of cycle. Okay, in half. If we draw the cycle, so in first half cycle, you can register write. In second half clock cycle, you can do register read. Okay, so that way in second clock cycle, the first half we are do nothing, but in the second half clock cycle, we are reading the register. Same for the fifth clock cycle. So in the we are doing the writing to the register in the first half clock cycle of fifth clock cycle. The first half of fifth clock cycle and second half clock cycle we are doing nothing. Okay, same here. Subtract instruction. ID stage. The second half is solid here. Write back stage. The first half is solid. For the third, you can see decode or you can reading the register in the second half clock cycle, and here you can writing into the register in the first half clock cycle. Okay. So hazard is a situation in which it prevents an instruction to execute in the designated clock cycle. So there is three type of hazard. First is the structural hazard, second is data hazard, third one is the control hazard. Structural hazard is when two instructions require the same hardware at the same time. And data hazard, the instruction requires the result of the prior instruction which is still in the pipeline. And in the control hazard, it is caused by the branch instruction.